Hello there, class. This is Grade 10 Mathematics, 3rd quarter, Module 4 from version 5. Our lesson for today is about differentiating permutation and combination. I am your teacher here, Mr. Anthony G. Arresgado of Bukidnon National High School, Division of Malaybalay City. Are you ready for the class? Let's go! The objective for today's lesson. At the end of this session, the learners would be able to differentiate permutation from combination in a given situation or activities. Now let us differentiate permutation from combination. Let us use this comparison chart. Okay, the basis for comparison. The meaning. For permutation, it refers to the different ways of arranging a set of objects in a sequential order. For combination, combination refers to several ways of choosing items from a large set of objects such that their order does not matter. Okay? Now, take note, for permutation, the order is very relevant. For combination, it is irrelevant. Now, the permutation denotes arrangement, sequence, lineup, schedule, or permutation. Now, for combination, selection, group, sample, and combination. Okay? Now, for permutation, take note that it's always ordered elements. Okay? Every element and whatever their order is, it counts. Okay? Now, for combination, unordered sets. Okay? So take note the comparison. For permutation, ordered elements. For combination, unordered sets. Now for answer. The question for permutation has this example. How many different arrangements can be created from a given set of objects? But usually, the question for combination goes like this. How many different groups can be chosen from a larger group of objects? Okay? Next, the formula. For permutation, it's the permutation of n objects taken r at a time is given by n factorial divided by the quantity of n minus r factorial. But for combination, it's the combination of n objects taken r at a time equals our dividend n factorial, our divisor r factorial times the quantity of n minus r factorial, where n is the total number of objects, r is the number of objects for permutation, and number of objects for combination there, for combination. Okay, let's have the following statements. For our activity 1, let us try to analyze whether the given situation or activity is a permutation or a combination. Okay, these are the statements. Number 1, assembling a jigsaw puzzle. Number 2, taking a picture with 5 people. Number 3, assigning seats to guests at dinner. Number 4, picking 6 balls from a basket of 12 balls. Number 5, choosing 3 household chores to do before dinner. Okay, let's just guess as of this moment. Number 1, what is your answer? If you guess permutation, then you are correct. Assembling a jigsaw puzzle, because you can start anywhere in a jigsaw puzzle. How about taking a picture with 5 people? That is a combination. And third, assigning seats to guests at dinner. That is another permutation. And number 4, picking 6 balls from a basket of 12 balls. That is a combination. And number 5, choosing 3 household chores to do before dinner. That is a combination. Okay? So please take a look at the activity and then analyze why it became permutation and why combination. Let's proceed to number 6. Forming a committee of 4 members from 16 people. Number 7. Selecting 4 posters to hang out of 8 different posters. Number 8. Selecting 8 people to form a student affairs committee. Number 9. Arranging 6 different potted plants from 12 potted plants. And number 10. Determining the top 3 winners in an M-top elimination round. So number 6. What do you think? Forming a committee of 4 members from 16 people? That is a combination. How about selecting 4 posters to hang out of 8 different posters? That is also a combination. Number 8, selecting 8 people to form a student affairs committee. That is another combination. Then arranging 6 different potted plants from 12 potted plants. That is a P. Yes, a permutation. Arranging. And number 10, determining the top 3 winners in an M-top elimination round. That is another P. Yes. So I hope at this point you'll be able to identify which is combination and which is a permutation. Let us have another activity. Activity 2. Take note of the underlined word or words, and it will tell us what they are. Is it a permutation or a combination? So we have number 1, specific order in seats. Number 2, numbering a particular order. Number 3, ordering a potted plant in a shelf. Number 4, listing the elements of subsets of a given set. Number 5, grouping 5 students for an investigatory project. Okay, so do you have answers already? Let's check whether your answers are correct or you need to change them. Let's go with number 1. That is permutation. A specific order. Okay, so order matters. Number 2, numbering in a particular order. Again, that is very good. How about number 3, ordering a potted plant in a shelf? Okay, if you answered permutation, you are correct. How about number 4, listing the elements of subsets of a given set? Take note also of the word subset. So this is a combination. And another one, grouping. That is combination. Very good if you got all correctly. Let's proceed to number 6 of the activity 2. How can we arrange 10 students in a line to go for snacks today? Number 7. How many codes can be formed in a lock requiring 4 unique digits chosen from 6 to 9? And number 8, in how many ways can 4 patients be assigned to 6 hospital rooms so that each patient has a private room? Now for number 6, as you can see there, the underlined word is arrange. So what do you think is the activity? Is it a permutation or a combination? So your answer is permutation because of the word arrange. That's correct. How about number 7? The underlined word is unique digits. Meaning to say, if it is a unique digit, then the order matters. And number 7 is, yes, permutation. And number 8, in how many ways can 4 patients be assigned? So the underlined word is assigned. And this is another permutation. Very good. Then let's proceed to number 9 and 10. 8 runners join a race. In how many possible ways can they be arranged as first, second, and third placers? Number 10. A box contains 4 red balls, 6 green balls, and 7 yellow balls. In how many ways can 6 balls be chosen if there should be 2 balls of each color? For number 9, the underlined word is arrange. Again, this is a permutation. For number 10, the underlined words are be and chosen. So be chosen. Is this a permutation or a combination? This is a combination. Yes. Very good. So that is how we differentiate permutation from combination. I hope you understood some of what we've discussed today. Okay? Now, if you have questions, class, please jot it down in the comment section of this video. Now for the assignment. Please identify whether each statement or question is a permutation or a combination. Number 1, so in how many ways can 10 people shake hands? Number 2, how many groups of 3 can be formed out of 10 people? Number 3, how many 4-digit numbers are possible if no digits are repeated? Number 4, how many sets of 6 questions can be chosen from a list of 30 questions? And number 5, if 7 numbered balls were to be drawn from a bag of 20 balls, how many unique batches of numbers can be drawn? Thank you so much for staying with me today. I am your teacher, Mr. Anthony G. Arresgado of Bukidnon National High School from the Division of Malaybalay City. Thank you so much. God bless you. Remember, math is fun and math is for everyone. Thank you. Bye-bye.